Hello everyone, welcome back to my channel. Today we are officially starting our calculus series and I will be covering every topic you need right here. I'm sorry for the delay over the last few months, but I am back and will be uploading classes frequently from now on. So let's get started with the topic called hyperbolic functions. So in these hyperbolic functions, we will precise the definitions and will try to understand the point of similarities and dissimilarities between the hyperbolic and trigonometric functions. So why trigonometric functions means in this chapter we will discuss about some trigonometric functions like sine x. So these are the ordinary trigonometric functions. By using these trigonometric functions, then coth x, sec x, cosech x. So these are the ordinary trigonometric functions. With the help of these ordinary trigonometric functions, we will write it as the hyperbolic functions as sine hyperbolic x, cos hyperbolic x, tan hyperbolic x. Just we will add h, which is read as, suppose I'm writing here, so we can read it as sine hyperbolic x, but we write it as like this, written as like this. Okay, so this is what the hyperbolic functions. Then sec hyperbolic x, cosec hyperbolic x. So in this chapter we will learn the similarity and dissimilarity between the hyperbolic and trigonometric functions. So let us derive some formulas for these hyperbolic functions. At first we will consider if x belongs to R. So as we know, we will derive by using the e to the power x formulas. So e to the power of x, which is equals to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x4 by 4 factorial and so on. Consider this equation as 1. Now, in the next step, let us replace minus x in the place of x. So, write it here, replace, I'm writing here, replace x by minus x. So, on replacing the terms, I will get the value as e to the power of minus x is equals to 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus x to the power of 4 by 4 factorial, then minus and so on. This is our second equation. Here I have taken the positive term since because minus x square is equals to x only, x square, positive. So as we know, the power of these terms, when the power is in the even number, positive even number, we will get the positive value. So this is what I got the second equation. Now add both the equation. On adding equation in 1 and 2, we will get, on adding these two equations, we get e to the power of x plus e to the power of minus x. Now 1 plus 1 is 2. Plus x minus x will be 0. The next term plus x square by 2 factorial plus x square by 2 factorial. See here, x square by 2 factorial plus x square by 2 factorial. We can write it as 2x square by 2 factorial. So plus 2x square by 2 factorial. Then this will be cancelled out since it is in positive term and this is in negative term. Then the next one will be 2x to the power of 4 by 4 factorial. Then the next term will be cancelled out. Here we will get x to the power of 5 by 5 factorial, and then here we will get x to the power of 5 by 5 factorial. So these two positive and negative values get cancelled out, and the next term will be 2x to the power of 6 by 6 factorial. If you see here, we get only the multiple of two values only. So and so on. So this is what we got here. Now in the next step we will do the simplification. See here, as we have here e to the power of x plus e to the power of minus x is equals to, we will take the common terms here, that is 2, then x square by 2 factorial plus x to the power of 4 by 4 factorial, x to the power of 6 by 6 factorial, and so on. So let's remove this 2. To remove that, we will divide the 2 both sides. So divide, no need to write here. So just divide 2 both sides. On dividing, we will get e to the power of x. So divide 2. On dividing, we will get e to the power of x plus e to the power of minus x, e to the power of minus x by 2. So here the 2 will get cancelled out. Then we get x square by 2 factorial plus x to the power 4. So here I made a mistake. When we remove this 2, here we get 1. That means 1 plus. So at the same, here also we get the value as 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial plus x to the power of 6 by 6 factorial, and so on. So this is our cos hyperbolic x value. As in the Taylor series, we get the cos x value as plus and minus. The signs are getting changed out, but here in the hyperbolic functions we got this cos hyperbolic x value as here 1 plus x square by 2 factorial plus x to the power of 4 by 4 factorial, and so on. So we can write it as the formula for the cos hyperbolic x as e to the power of x plus e to the power of minus x by 2. So similarly, if we want to find the value for the sine hyperbolic x, we will go for the equation 1 and 2. We have to subtract these two. We have to subtract these two equations. So write it here for sine hyperbolic x. Subtract equation 1 and 2. On subtracting these two equations, we will get e to the power of x minus of e to the power of minus x, which is equals to, if you see here, 1 plus 1 is, so here 1 plus 1 is 2, but we are doing the subtraction. So 1 minus 1 is 0, then x minus of x minus of minus x will be 2x. Similarly, x square by 2 factorial minus x square by 2 factorial. Here we will get all the odd terms. That means the power which is in the odd term, we will get those values here. So which is equals to 2x plus 2x cube by 3 factorial plus 2x to the power 5 by 5 factorial, and so on. So now take the common value 2. On taking common, e to the power of x minus e to the power of minus x, which is equals to x plus x cube by 3 factorial plus x to the power of 5 by 5 factorial, and so on. Similarly, as we have done for the cos, we will divide to both sides. Here we get e to the power of x minus e to the power of minus x by 2, and this 2 will get cancelled out after dividing the value 2 here, and this is our sine hyperbolic x value. So this is our sine hyperbolic x value. So this is our cos hyperbolic x formula, and this will be sine hyperbolic x formula. Now easily we can derive the other terms formulas. So as we know, the inverse reciprocal values of trigonometric functions, that means we used to write sine theta is equals to 1 by cosec theta, and similarly for sine, then cos theta, then tan theta, coth sec theta, then we go for the cosec theta. Just we will write the reciprocal of these values, 1 by sec theta, and here we can take the reciprocal. Otherwise we also have the formula called sine theta by cos theta, and here for the cos theta by sine theta. Since we have already formulated the formula for the cos and sine, we have taken the tan theta value like this, and for the sec theta 1 by cos theta, and this is for 1 by sine theta. We already found the value for sine and cos. Now we will go for the tan. So we can write it as tan hyperbolic x, which is equals to, as we know the formula for sine is sine hyperbolic x. So sine hyperbolic x by cos hyperbolic x, which is equals to e to the power of x minus of e to the power of minus x by 2 on dividing e to the power of x plus e to the power of minus x by 2. Now cancel out these two values. We get tan hyperbolic x is equals to e to the power of x minus of e to the power of minus x by e to the power of x plus e to the power of minus x. So this is our tan value, tan hyperbolic x value. We got this value. Then similarly we will find for the next one, that is coth. So in the coth value we will do the same as we have done for the tan hyperbolic x. So coth hyperbolic x, which is equals to e to the power of x plus e to the power of minus x by 2 whole divided by e to the power of x minus of e to the power of minus x by 2 on cancel outing these two values because it gets reciprocaled out. So coth hyperbolic x is equals to e to the power of x plus e to the power of minus x by e to the power of x minus e to the power of minus x. So this is our coth hyperbolic x formula. Then the left out values are, we got the coth value, and the left out values are sec and cosec. So if you see here, sec value, sec hyperbolic x value, which is a reciprocal of cos hyperbolic x. So what is the what is the formula of cos hyperbolic x, which is nothing but e to the power of x plus e to the power of minus x by 2. On reciprocating this value, 2 by e to the power of x plus e to the power of minus x. So this is what we got, the sec hyperbolic x is equals to 2 by e to the power of x plus e to the power of minus x. So this is our sec hyperbolic x formula. Similarly for cosec hyperbolic x, we know the formula for cosec theta is 1 by sine theta, and the sine theta value, which is nothing but, here we have written e to the power of x minus e to the power of minus x by 2. So we write it as 2 by e to the power of x minus e to the power of minus x. So this is our cos hyperbolic x formula. So these are the 6 formulas of hyperbolic functions. So we found all the 6 formulas for the hyperbolic functions. Next we will discuss some more formulas by using these hyperbolic function formulas. So let's get started with the function. First formula, consider the first, write it as formula 1 because we will discuss each type of formulas by using the hyperbolic functions. So in this we will discuss about consider x and y belongs to R. So there are few formulas which we have already learned in our higher secondary class in the lesson called trigonometric functions. Just similar way we will write some formulas and we will do the derivation of each. So sine hyperbolic x plus y is equals to sine hyperbolic x into cos hyperbolic y plus cos hyperbolic x into cos hyperbolic y. Sorry, sine hyperbolic y. Then we will write the next formula is sine hyperbolic x minus y, which is equals to sine hyperbolic x into cos hyperbolic y minus cos hyperbolic x into sine hyperbolic y. And then the third one is cos hyperbolic x plus y, which is equals to cos hyperbolic x into cos hyperbolic y plus sine hyperbolic x into sine hyperbolic y. And the last formula of this is cos hyperbolic x minus y is equals to cos hyperbolic x into cos hyperbolic y minus sine hyperbolic x into sine hyperbolic y. So these are the formulas of, so we will derive these formulas here. Let's prove these formulas. So first one which is given, let write it as the left hand side, so right hand side values to get the left hand side value. So which is given, RHS side is sine hyperbolic x into cos hyperbolic y plus cos hyperbolic x into sine hyperbolic y. So as we know the formulas for sine and cos, so the formula of sine is e to the power of x plus e to the power of minus, sorry here we have to write minus, so minus e to the power of minus x by 2. And for cos value we know e to the power of x plus e to the power of minus x by 2. Since we have here y, we have to write here e to the power of y plus e to the power of minus y. Similarly here cos, for cos hyperbolic x e to the power of x, because here the term is given x, variable has given x, plus e to the power of minus x by 2, and then multiply e to the power of y minus e to the power of minus y by 2. So I'm multiplying these two values, 1 by 4 e to the power of x minus e to the power of minus x, then again multiply e to the power of y plus e to the power of minus y, plus 1 by 4 multiple of e to the power of x plus e to the power of minus x e to the power of y minus e to the power of minus y. So this is what we got the formulas. Just multiply out these values. Just multiply these values. 1 by 4 e to the power of x will get multiplied with these terms. So e to the power of x into e to the power of y plus e to the power of x into e to the power of minus y, and this value will get multiplied with this whole term. So minus e to the power minus x into e to the power of y, then again minus e to the power of minus x multiple of e to the power of minus y. So this is what we got the term here. Then the next step, let's go for the next step. Here we get plus 1 by 4. Now multiply this value with these terms, e to the power of x into e to the power of y plus e to the power of x, sorry, here plus minus gets multiplied out, so we get minus e to the power of x minus into e to the power of minus y. Then so here we have multiplied e to the power of x with e to the power of y and e to the power of x with e to the power of minus y. Then we will go for the next one, plus e to the power of minus x into e to the power of y, then minus e to the power of minus x into e to the power of minus y. So this is what we got after multiplying the each term. As we know, when the bases are same, let's give an example. Let us consider x to the power of 5 and x to the power of 2. When we multiply these terms, we will write it as x to the power of 7. As we know the formula, a to the power m into a to the power of n is equals to a to the power m plus n. So similarly, we will follow this rule. Okay, this is our example. Similarly, we follow this rule. We write this, the above equation, this equation we will write it as 1 by 4 e to the power x plus y plus e to the power x minus y minus e to the power of minus x plus y minus e to the power of minus x minus y. If you see here, I have just added the powers and I have written here. Then the next one, 1 by 4 e to the power x plus y minus e to the power x minus y plus e to the power minus x plus y minus e to the power of minus x minus y. So in the next step, we will take the 1 by 4 as common. So 1 by 4, and see here e to the power of x plus y, positive term and negative term will get cancelled out. So here we have only the e to the power of x plus y and positive term of e to the power x plus y. So we have 2 e to the power x plus y. And the next one, positive term of e to the power x minus y and negative term of e to the power x minus y get cancelled out here. And this negative term of e to the power minus x plus y, positive term of e to the power minus x plus y, let's get cancelled out. And then e to the power minus e to the power minus x minus y minus e to the power minus x minus y. So we write it as minus 2 e to the power minus x minus y. Then if you see here, we will take the 2 as common. 2 by 4 e to the power of x plus y minus e. So take the negative term as common, then we can write it as e to the power x plus y. So here the value gets cancelled out. So we can write it as e to the power x plus y minus e to the power minus x plus y by 2. So which is our sine hyperbolic x plus y formula. As we know, sine hyperbolic x, which is nothing but e to the power of x minus of e to the power of minus x by 2. So here we have the x value as x plus y. So we got the sine hyperbolic x plus y formula, which is equals to LHS. Similarly, you will do by yourself the second one, which is given sine hyperbolic x minus y. You will do this one by yourself. So do it yourself, this question. Let's go for the third one. The third question is given cos hyperbolic x plus y. So we have to prove this. We have to get the cos hyperbolic x plus y and the RHS side which is given. So the RHS side is given cos hyperbolic x into cos hyperbolic y plus sin hyperbolic x into sin hyperbolic y. So here we will solve. As we know, just put the formula e to the power of x plus e to the power of minus x by 2. As we have done the previous question, we have to do the same steps here. E to the power of y plus e to the power of minus y by 2, then plus e to the power of x minus e to the power of minus x by 2, then e to the power of x, sorry, here we have to write the y since it is given in the y form, e to the power of y minus e to the power of minus y by 2. Now let's get multiply these values. So 1 by 4, e to the power of x will get multiplied with these terms. So e to the power of x into e to the power of y plus e to the power of x into e to the power of minus y. Then again this value will get multiplied with these two. So plus e to the power of minus x into e to the power of y, then plus e to the power of minus x into e to the power of minus y. Similarly, take the other part 1 by 4. Again multiply this value with these two. So e to the power of x into e to the power of y, then minus e to the power of x into e to the power of minus y. Here positive negative will get multiplied and we get the negative value. Then this value will get multiplied with these two. So minus e to the power of minus x into e to the power of y. Then plus. So minus is nothing but plus e to the power of minus x into e to the power of minus y. So here also we will follow the formula, which is if the bases are same, we just multiply the powers, and here we will take the common term 1 by 4, then write it as e to the power x plus y, then e to the power x minus y plus e to the power minus x plus y, and then plus e to the power minus x minus y, and then plus e to the power, here I have taken the common because 1 by 4 is common here in the previous step. So the next one will be e to the power x plus y minus e to the power x minus y minus e to the power of minus x plus y, then plus e to the power of minus x minus y. Now let's check where the values gets cancelled out. If you see, e to the power x plus y positive term and the positive term is there, so 1 by 4 2 e to the power x plus y, then positive term of e to the power of minus e to the power of x minus y, and then negative term will get cancelled out here. Similarly the other one, positive term of e to the power minus x plus y, the negative term e to the power minus x plus y gets cancelled out here, and then we have plus e to the power minus 2 times e to the power x minus y, let me write this correctly, plus 2 e to the power minus x minus y, then here we will take the 2 common and we get e to the power x plus y, then plus take the negative term as common minus y. So we have, on cancel outing these two terms, we get e to the power of x plus y plus e to the power minus x minus y, multiple of minus x minus y by 2. So which is our cos hyperbolic x plus y formula, and this is equals to RHS side. No, this is our left hand side. We have this value in the left hand side, so LHS side. So we have proved the third formula also. Similarly, let's go for the fourth one. So the fourth one also you will do it by yourself. do it yourself. There is nothing complicated in this step. Just we have to put the formulas and we have to prove for the value. So this is what we have discussed in this class. So in the next class we will discuss some more formulas of the hyperbolic functions. So you can find the detailed notes from this topic via the link in our Telegram channel, which is located in the description. So go for it. So that's it for today. Thank you.